Good morning everyone. So this video will form part 2 of the new refrigeration project. I've actually been testing it. I've got it all assembled. So what I'm going to do is put some refrigerant in it and show you how it performs. It's already got some refrigerant in it, but it's really just not very much at all. It's just enough to keep a positive pressure inside, really, because I recovered it all out yesterday, just using the high side back to the recovery cylinder, which is down here. So I'm going to fill it with refrigerant until it's running stable, and I'll show you how you can fill refrigerant into a system, an unknown system, when you don't know how much refrigerant it actually needs. This technique only really applies to a capillary tube system though. So what I'm going to do is switch the system on, and what you'll see is, as I'm putting the refrigerant in, is frost formation on the capillary tube. And eventually, when there's about enough refrigerant in it, I find that all the frost formation starts moving along until it eventually doesn't form anymore, until it's eventually there's no frost, and the only frost is the point where the capillary tube is entering the evaporator. So I'll switch the system on just now. I've got a 12 volt fan in front of the condenser cooling it, but I may use a 230 volt fan I've got, but it's not very powerful, sadly. So I'll be switching on the system now, and I'll get some refrigerant in. Better put on the condenser fan. So I'm just waiting for frost to start appearing on the capillary tube. The low side pressure is still just at 0 just now. There's not very much going on there. So it does take quite a bit of refrigerant in this system. In my test last night, the high side pressure was about 150 psi. So things are beginning to frost up now. We've got a little bit of frost forming just here. So it doesn't seem to be forming anywhere else. So I'll let it build up for a bit. Yeah, it's forming back to here now, so I'll add in more. You should see that starting to move with each addition. So it goes up there, so it moves there. As you can see, each time I let in a load of refrigerant, the frost moves along. So that's one way to gauge when you've got the right amount of refrigerant in. That's another lot going in. Seems that as it gets closer to the end, it takes more and more refrigerant to get the frost to move back. That's still not quite enough refrigerant in it yet, so once that stops, once all that frost is gone, that should be enough. Yeah, it's going to shift along now, but it's taken a lot of refrigerant to get it to move. I think that should be enough. So here's the resulting pressures. That's about what it was on my test last night, but there's still not quite enough refrigerant in it. I've noticed that the frost has moved back down the capillary tube a bit, so I think I should add just a little bit more so I could get the pressures just right. But the pressures all depend on what compressor you're using, what length of capillary tube you have, what temperature condenser is at. There's so many different variables. But the pressures that seem to work best in this system are just over 10 psi, maybe about 12 psi on the low side. And the high side pressure is not something you have much control over, really. That's all dependent on the condenser temperature, and if the system gets overcharged, the high side pressure will start to rise quite rapidly. Because if I add in refrigerant just now, the high side pressure doesn't do very much really, but putting too much in would make that shoot up, because the condenser just can't condense. The condenser won't work effectively, because if you have so much refrigerant in a system, the condenser will just start to fill up. Then the only place with actual gas in it will be like just the very top, because normally in a condenser, like I may only have liquid and about the bottom portion, and the rest is full of gas. So it's never ideal to overcharge a system. And the discharge temperature yesterday was absolutely roasting, but it's not so bad today. But I think that's just mainly because the compressor's been cold started, so it may take a while for the discharge pressure to go up. But it was so hot that I couldn't even keep my hand on it. So the refrigerant in this is R290, so I could say that with the pressure down that low, that I think we're operating an evaporator at roughly about minus 30 Celsius. The boiling point of R290 is minus 40, I think. I'm very sure it's minus 40, so at about this temperature, running about minus 30 on the evaporator, I'm sure. So this capillary tube is a bit too restrictive for this purpose. For this sort of thing, ideally I'd be looking for an evaporator temperature under full load of about maybe minus 10 Celsius. So this is quite restrictive and inefficient for this application. So I could maybe fit a better capillary tube on, which will result in the low side pressure being a bit higher and being able to move more heat. But now the discharge temperature is pretty roasting, and the condenser is really cold down at the bottom, so that's working really effectively. Yeah, it's pretty much cold down at the bottom, so it's working. That's fine. The condenser is a good size for this. I did come out of a dehumidifier. So I was doing a bit more testing there, just with no load on the system. And with no load, liquid floods back into the compressor. So there probably is still too much refrigerant in it. But I suppose if I keep it under load to prevent liquid going back into the compressor, it won't really be a problem. It doesn't seem to be overheating or anything like that, so that's always a good sign. So I've been at it a bit more, and I've installed the pump, which is down at the bottom of this pool of antifreeze, and I've got a filter here which just filters out any things that may fall into the bucket. The antifreeze isn't even replaced because it's got a funny smell to it, and I don't think it's as effective as it was, so I'll get some more eventually. I was playing about with the refrigerant charge with the system under no load earlier, so when I adjusted for no load, as you can see, the capillary tube's position of the thrust there has gone back a bit, so put a bit more gas in it just now. Yeah, as you can see, our low side pressure is, well, too low, so should be about just over 10 psi, about 12 psi or so. Now, as you can see, I've also put a shroud around the condenser fan, so that makes the condenser even more effective. I think that's even helped to reduce the high side pressure a bit as well, so that's less power consumption, more efficiency. I don't actually know what temperature the water is, so I should grab my thermometer and check. So the water bath is minus 4.6 just now, so the system seems to be doing quite well. It certainly reaches a lower temperature than the old one, and quicker too, but with the water that cold, when I run the air compressor, the water will just hit that coil there and freeze, blocking it, so I wouldn't run it at this very low temperature when compressing air. So for the air compressor use, I might just have the water bath at 1 Celsius, so that will get out as much water as possible from the air. So that's it, all done just now anyway, so I may make a future video about putting a less restrictive capillary tube on this so I can move a bit more heat. So the evaporator is just operating far too cold, I think. It's not on just now, but it's so cold that my fingers just stick to it instantly, so I will see about choosing another capillary tube. I've got stuff somewhere. I'm sure I've got some stuff up inside here. I've got lots of different capillary tubes and stuff in here, so I can maybe grab some. I was thinking this one. Let's see. Yeah, this one here might do. I'm not sure what length or size it is, but I'm thinking it may be a bit better. I know that it's got a larger, it's larger internally than the stuff that's on it just now, but it's not very big. I reckon it's maybe about 0.8 millimeter maybe.